So we skipped section 5.3 to go talk about isosceles triangles and equilateral triangles. And then we're going back now to talk about the side angle side theorem, the side 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 theorem, and the hypotenuse leg theorem. So a combination of those two. So first of all, triangles are congruent if all the corresponding parts are congruent to all the corresponding parts. They have to have exactly the same size and shape. Easy to tell that you have translated, rotated, or reflected them. Nope, you don't have to write this down, okay? But all the sides and all the angles have congruent measures, okay? So in the past, when our book asked us to prove two triangles were congruent, remember that one proof that would have been a half a page long if I had had you write that one out? Okay? We don't want to have to do that. We want like a 3-line proof. Okay? That's what we're going to be able to get to with this. So first of all, instead of having to show that all 3 pairs of sides and all 3 pairs of angles are congruent, we're going to be able to use something like this. So in the top of your foldable, this is what we write down. The side angle side theorem says that if 2 corresponding sides and the included angles of 2 triangles are congruent, then those triangles will be congruent. Okay. Right here. If 2 corresponding sides and the included angles of 2 triangles are congruent, then the triangles are congruent. Key word here is included. What does included mean? With, right? If someone is included in your group of friends, they're a part of, with, right? In the middle of, okay? So here's what we're talking about with the with included angles. Okay? I have a side that's congruent to a side. I have another side that's congruent to a second side of a second triangle. Okay? And then I have an angle that is congruent to an angle. And that angle is the included angle. It is between those 2 sides. So 2 sides and the angle between them congruent to 2 sides and the angle between. If those are the parts that are given, then you can prove those triangles are congruent by side, angle, side. Okay? One way I remember side, angle, side sounds like the word SAS, right? Okay? So don't sass your parents, especially this time of year if you want to get some gifts in a month, right? Okay? SAS, side, angle, side. The order in which they're written and the order in which the sides and angles appear is important. Okay? So, first of all, how are we going to name this particular triangle? ABC. So if triangle ABC is congruent to this triangle, we want to be able to name it appropriately as well. So AB is the side that has just a single tick mark, and BC has 2 tick marks. So we have to come over here to the single tick mark side first, and then to the double. So D, E, F. They will not always be in alphabetical order, so you have to be careful when you're naming the triangles. Okay? So far, so good? Key word, included. 2 sides and the angle that's between them. The angle that's formed by those 2 sides. Okay? Next slide. Side, side, side theorem. Put a bunch of S's together, it sounds like sound a snake makes. Okay? So we don't sass our parents. And we can use the snake sound, side, side, side. Okay. Side, side, side says that if the corresponding sides of two triangles are congruent, then the triangles are congruent. Get a side congruent to a side, another one congruent to another one, a third one congruent to a third. Those triangles have to be congruent. So here's our image. Notice no angles are marked here. We only have sides marked. So AB is congruent to XZ. Single tick mark. Okay. Double ticks at BC and at XY, and triple tick marks here at AC and YZ. Three sides congruent to three sides. So we can say that these two triangles are congruent by side, side, side. Okay. So how are we going to name this first triangle? ABC sounds good to me. We have to be careful again to make sure that we use the appropriate order. A to B was the single tick mark, right? XZY. Let's see if we're correct. X to Z is the same as the single tick mark for A to B. B to C was double tick mark, and Z to Y was triple tick mark. Does it work? Nope. So ABC, single to double to triple, right? Single to double to triple. Z, X, Y, everybody okay with that? So we have to be cautious because they won't necessarily put them in alphabetical order. Everybody's good? Next slide. So here's where you may want to take some notes outside of your foldable. Okay, we wanted to decide if we can prove or show that these triangles are congruent. If so, which theorem would do it? So here's our first example. So we think it might be SAS, side angle side. We have agreement, okay? And it is because we have a side, the included angle, and another side, congruent to a side, the included angle, and the other side. That angle has to be between the two. You can't jump around and go too far. You can't. They have to be all three next to each other. Okay? All right, here's another example. What about those two triangles? SSS, everybody agree? We have three pairs of sides congruent to three pairs of sides. So yes, that one is by SSS. Okay. Okay, how about this one? Do we have any angles? Is there any way we can get any angles using any theorems that we have? It looks like it's right, but we can't be sure. Okay, so we can't get any angles, right? Unless they give us that mark, we can't know for sure that's the right angle. Side, side, side. Does side, side, side work? I have a single side congruent to one side, a second congruent to another. Is there any way we can get the third one? Yeah, it shares the same line. That angle, that side is equal to itself, right? So we could use reflexive property to be able to prove those are congruent. So yes, this one is a side, side, side. Okay, we're good? Does everyone understand why this one's side, side, side? Okay. All right. What about those two? Okay, we've got an angle, right? We've got two sides, so we think side, angle, side. Does it work? Okay, why doesn't it work? Correct. The angle is not between those sides. Okay. Does everyone see why? Not an included angle, is it? Okay. So if we were going to try to do this, notice that we'd have to wrap this way, use an angle, side, side. Spells a bad word, doesn't it? And it doesn't work in geometry. Okay? Okay? Or we could say side, side, angle. But again, not going to work because side, angle, side is our choice. We would have to have this and this angle given to us for that to be side, angle, side. Bless you. Okay? Everyone understand the distinction? Okay. Last example on this one. What about this? Very good. Vertical angles, right, are always going to be congruent. So by using that other theorem that we know about, we can make these two angles congruent. Now does it work with side, angle, side? Are those the included angles? So this is side, angle, side. Okay? Everyone understand the distinction? What included angles mean? It's important to understand that. Okay? All right, let's talk about a right triangle. A few days ago, we talked about an isosceles triangle having special parts. It had a base angles, legs, and a vertex, right? Right triangles have special names too, okay? Right triangle has a right angle, obviously, hence its name. And what are the sides of a right triangle called? Legs and hypotenuse. Your legs are the two sides that meet to form the right angle. The hypotenuse is opposite the right angle. It's the longest side. Okay. So we want to make sure that you understand which ones are legs and which one's the hypotenuse. Locate the right angle. Opposite it is the hypotenuse. Creating that right angle are the legs. Okay. So here's our new theorem. Hypotenuse leg. Okay. Hypotenuse leg theorem says that if the hypotenuse and a leg of a right triangle are congruent to the corresponding parts of another right triangle, the corresponding leg and hypotenuse of another right triangle, then those two triangles have to be congruent. If the hypotenuse and a leg of one right triangle are congruent to the corresponding parts of another right triangle, then the two triangles are congruent. So there's our example figure. We have two right triangles. The hypotenuse of one is congruent to the hypotenuse of the other. And a leg of one is congruent to a leg of another. Therefore, those two triangles have to be congruent by hypotenuse leg. We good? Okay. So let's see if we can prove some other triangles congruent. Oh, we got to do that tomorrow. Okay. So, assignment is going to be a worksheet.